Hi Honors Kids, this is your last screencast of the day. There'll be another one coming up probably on Tuesday or Wednesday of this week, but this is your last one. Hopefully we'll keep it pretty short. But we're going to be talking about this dating rocks assignment. So if we were in class, we'd probably do more hands-on activities and kind of class discussion and things like that on this topic. But if you just Google, how do we know the age of the Earth? You can just you could probably click on any one of these. We'll just click on this top one up here. It says, how science figured out the age of the Earth. It says, for centuries, scholars sought to determine Earth's age, but the answer had to wait for careful geological observation, isotopic analysis of the elements, and an understanding of radioactive decay. Now, you guys with your knowledge, know what isotopic analysis of elements is and the understanding of radioactive decay. You know those things. So scientists are actually able to figure out the age of the Earth and the age of certain fossils and things like that because of radioactive decay and because of analyzing how many isotopes have undergone radioactive decay. So you guys are going to be working on this CAMI assignment about dating rocks to figure out the age of the rocks. And so it's a pretty cool thing. If you want to learn more about how to figure out, ages of fossils and rocks and how radioactive decay works and half-life works with that, you're welcome to Google more things. Like I said, we probably would have read different articles and stuff like that in class, but I don't want to overload you guys with too much work online right now. So we're just going to do this quick activity to see how well you guys can understand this topic. So read the introduction by yourself, define radioactive decay and half-life, and then move on to this activity. Now this activity has lots of different instructions, and I know it can be kind of confusing, so I'm going to walk you through how to do this, okay? And I even did this first one for you, as you can see. So I'm going to walk you through how I got each of these numbers here. So what we're going to do is we're going to just look at this number 1 right here, okay? And for this, we need to figure out how old that sample is. So this sample is, like our fossil or something, and the different dots in it are our atoms and different isotopes that are found in there. And so for this number 1, we're going to be down here, and we know that it is K40. So remember, K is potassium. So this is different potassium atoms in number 1. We know that the yellow ones are our parents. And so parents are ones that haven't undergone the radioactive decay yet. They're the ones that are still in an unstable state. And then we know that our purple ones are ones that are our daughters. So daughters means that they have undergone radioactive decay. We can even see that it has changed from this into this lead-208. So when it undergoes radioactive decay, it goes from the thorium to the lead. So the first part in our data table is asking us for the number of parent isotope atoms. So the parents, again, we know that they're yellow, so we need to count out how many yellows there are. So we see there's 1, 2, 3, 4 yellows. So we go put the number 4 there. There you guys go. So then we need to figure out the number of daughter isotope atoms. So that's going to be our purple ones. So I counted these out for you guys. We won't count them all, but you see, you just count all the purple, like 1, 2, 3, 4, 5, 6, so on until you count all the purple ones. And that one has 28 total. So now we figure out the original number of parent isotope atoms. So here I said that any atom that is now a daughter was originally a parent. So we need to figure out the original number of parents. So you can count up all the purple and all the yellow, or you can take 4 and plus by the 28, and that's going to equal 32. So that's our total original number. So to figure out our number of half-lives, we have to think we started off with 32, right? And now, through a bunch of half-lives, we eventually get to only having 4 parents left and having 28 daughters. So if we take 32 and we divide it by 2, remember, you're welcome to use a calculator. It looks like we're going to get 16. So that's after 1 half-life. Okay, so we get 16 after 1 half-life. Then if we do 16, we divide it by 2, we get 8. So that's 8. So now we should have, we start off with 32 yellow. Now we have 16 yellow after 1 half-life. Now we're going to have 8 after 2 half-lives. And then remember, we have to do that 8 and divide it by 2 again, and that's going to equal 4. So this is our number after 3 half-lives. And since we have 4 yellows, 4 of the original parents left, we know that if we have 4, it's going to have gone for 3 half-lives. So with that, we put the 3 here. And now we need to figure out our age of the fossil. So we looked at this K40, it has a half-life of 1.3 billion years. So if we know it has a half-life of 1.3 billion years and it's gone through 3 of those cycles, we take 1.3 and we times it by 3, and we're going to get 3.9, which we put in there. So that's how you figure out each one of those different cells, what we put in them. So I want you guys to do number 2, 3, 4, 5, and 6, using these different ones up here. Be careful, because when you start doing 3, 4, 5, and 6, you're going to start either using this one or this one, depending on the color. You can read the steps if that helps you. You can go rewatch this video if that helps you. But this is basically the process science go to figure out how old rocks are, fossils are, the earth is, things like that. This is a little bit more basic than what they do, but this is the process. And so you guys are starting to do some real science now, and it's really cool. So let me know if you have any questions, rewatch the video if you need some help, or reach out to me. You just need to do these 2 through 6, and then remember to also put in the definitions up top and turn it in by Friday, and you guys will get your points. Have a good rest of your week. Let me know if you have questions, and I'll talk to you.